Okay, hi everybody. This is Griffin here. Really nice meeting you all today. I wanted to finish up what we didn't get to in lecture. Sorry that we have to do it this way. This is kind of always a jam-packed week of the semester. In future weeks, this very likely won't have to happen. So I appreciate everyone's good humor in going over this, and we'll go over this again, although a little bit more rapidly next time. You also don't have a whole lot of work to do this week, so hopefully this doesn't take too much of your time. And what I'm going to show you now is also probably going to be for some people more or less review. But since I know we have a wide range of familiarities with Stata, I did want to show this so that we can make sure that everyone is starting more or less on the same page after this week. So let's dive right in. You might recall that we were wrapping up by talking about Dofiles. Remember that Stata basically has this kind of interface as a default. We talked about the command window, the results window, the history window, and the variables window, and what each of those things does. But remember that even though this is the way that most of you are probably familiar with Stata, and many people may not have done anything really with the Dofile, that the Dofile is a very useful tool because it allows you to record all of your commands in one place and to basically write a script. Script is actually the term for a Dofile in a comparable piece of software called R, and in some ways it's a more evocative name. This script can be run so that you can, A, just execute one command and then get all of the analysis that you'd want for a project up. And B, it's also a way to save your work that's very natural and convenient, whereas some of the other methods people might use to save a set of commands, if they're only using the command window, are kind of clunky by necessity, because we remember that the command window, putting anything in there does not save, basically, when you close the program. So we want to avoid some of those bad habits. I've heard of everything from people leaving Stata open for months at a time on their computer because they were afraid to close it because they knew the progress would not save, or people like writing down commands by hand in a separate piece of software like the notes application and then copying and pasting them back in. And those are hard habits to break. You know, I understand that it can be difficult to learn, but that's really what the point of this course is we want to set aside some of those habits that may be useful early on, or might be less intimidating than a Dofile early on, but are not good habits, and they can be, in the long run, really detrimental to your further progress. Okay. So I left off, I believe, by showing you what this empty Dofile looked like and talking to you about how you can use the command window and the Dofile in tandem. So you want to use the command window basically as a place to test out commands, and then you want to paste them into the Dofile when you are confident that the command that you've written works and produces the result that you want. And we talked about how to do that a little bit during the lecture. So I also showed you this example of what a finished Dofile might look like. This is based on the data analysis project code that I put together last semester for my students in Social 360. You can see that code here. And as I noted here, for some reason, this hyperlink didn't really want to work, so I manually pasted it down here. So I can type that into the browser, then go check it out. Shouldn't be a period there. This is a public folder, so you can access this, and the code is in here. You absolutely don't have to go look at this if you don't want, but if you're refreshing yourself on Stata and you're already feeling pretty confident and you want to remember what are some common Stata codes, what can you do in Stata, like how do I call certain commands, and basically what are the key techniques in any statistical analysis, you can check out the code and data here. This, and this are the three possible data sources. This is the actual code. You can just click and download if you want. And then I actually also have some video tutorials in here for how to carry out different kinds of projects. So if you have two quantitative variables, for instance, you would be interested in regression. If you have a couple of categorical variables, like I think this one, hover here for a second. Yeah, you might want to do a chi-square test. You can also think about doing a two-group proportion test as well right here. So Again, these are just supplementary, but if you're wanting to refresh yourself on the math side of things, you're more than welcome to. It won't be directly tested, but I think this course will be a lot more interesting and fun if you have some ideas in mind of the kinds of that kind of analysis. We will do some basic math, but it'll be kind of ad hoc. Okay, so that's what a Dofile looks like. We're going to look at a concrete example soon enough. So that's just kind of an illustrative way to think about it. So let's go ahead and go to the course website now and get the Dofile that we're using. And I'm just going to basically download the file right to the desktop or to your downloads folder or wherever you want to put it just for the time being. And then I'll show you later on how to properly store the files. We'll download this. And we'll open this here. And notice that when you double click a Dofile, it just automatically opens Stata overall. So we've opened the Dofile and we've opened this command window here. So let's go back to the Dofile. By the way, a useful shortcut, the way that I just very quickly tab between two open windows of the same program is on a Mac, Command tilde. Tilde is the kind of curly sign that's used frequently in Portuguese and Spanish, probably some other languages too that I just don't speak. But it's in the top left corner of your keyboard if you have a standard keyboard setup. So Command tilde, there's probably something comparable in Windows. Okay, so yeah, let's go ahead and just talk about the purpose of this Dofile really quickly. Basically, this is just meant to show you how to write comments in Stata because that's a component of your first assignment that's due next Monday, which is your reading notes. Again, even if you're already familiar with Stata to a large extent, you may not know much about making your own comments, or you may have seen them, but you may feel a little bit uncomfortable in how to write them. So that's sort of the purpose of putting this together here. I also want to go ahead and show you our basic header in Stata. So something that we'll always put at the top of our Dofiles. From here on out, it'll be kind of a rote thing, but I think it's kind of nice to know why you would do this stuff. I sort of learned it by rote and then only later on learned what I was doing. And to be honest, it gave me a better appreciation for why I should do this stuff. And I think conversely, when things aren't really explained, sometimes it can feel kind of silly, and then you don't do stuff that actually might be kind of important. So that's sort of the aim of this document. Yeah. So all this stuff in green here is commentary. That's where I want to start. So commentary in Stata is basically a way of making notes on the stuff you're doing, which is really useful because you may want to write down for your own sake why you did something a certain way. Or if you're giving the program to someone else, they may not know why what that command does or why you would bother doing that. Of course, you can even use a Dofile in Stata to simply write up a whole set of notes. You don't have to have any actual commands in there at all. It can just be a text document. So this stuff in green, Stata basically, like the distinction between a comment and a command, besides the color, is that Stata won't try to process this as a request or a call to any particular function. It will just reproduce it on the screen. So I can show you that now. You can click do, and this just pops it up in the results window. And later on, we'll see in our log files, to be explained momentarily, it will also show up in our log files. So it's a nice feature. We can just get this stuff up on the screen if we want. Notice that you can't really do that in the command window. So if I type something like, here is a note, notice that the command window, if you just type that in there, it doesn't work. So this is another aspect of Dofiles. Technically, you can do comments in the command window in a sort of tricky way, but if you're going to write commentary on your notes by far, or on your commands, sorry, for a variety of reasons, doing it in a Dofiles makes way more sense. The stuff in blue and black, or the colors might be slightly different depending on the device you're using, but basically the stuff that's not in green is going to be your actual commands. And what that means when I say command, like, again, what's the distinction? A command tells Stata to perform a really specific numeric or graphical operation on the data that you have. And it has to be written in a very specific way. And there are all kinds of ways to go wrong. I show some examples later on so that oftentimes it's informative to know what doesn't work, or what it looks like when things go wrong is to know what it looks like when they go right. So we'll get to that in a little bit. But that's sort of the difference, is that these commands are actual requests to Stata to do something in a particular way, and you have to be really precise about it. So to get stuff into this green text, there's 3 different ways to do it. For the time being, though, and you can see here, this is what how I've gotten it here. I just want you to know that you can place things in what are effectively kind of like parentheses. So you open it by writing / asterisk, and you close it by writing */ There's a couple other ways. We'll get to that in a moment, but it makes more sense, I think, to go over sort of the basic header for Stata, or as I've called it here, coding etiquette and basic setup, before we go much further. Because we're going to put this at the start of every Dofile that we do, and from here on out, you don't need to explain it or necessarily understand too well everything that's going on. But again, I think it makes sense to just show it at least once. So we'll run all of this. And to run parts of a Dofile in Stata, incidentally, you just highlight and then click do. Now, it's generally not a great idea to do this if you are not doing it as I am for the sake of pedagogy. And one reason for that is that sometimes the rules are a little bit unclear. It depends on where a comment starts and basically where it ends. So for instance, if you just highlight like one line here and then run that, notice that it only pulls up this one line, and sometimes that will and sometimes that won't actually successfully execute the command. So just a word to the wise, in general, you want to get in the habit of writing elegant, parsimonious Dofiles where you can just run the entire thing. But since I am explaining what each command means, I'm of course going to go line by line. Okay, so let's start with this. You're going to see this at the start of all the Dofiles. Capture, log, close. Basically, this tells Stata to close the log if any is open and do nothing if no log is open. Log is a way of recording the output from Stata from an entire Stata session. So it's actually a lot like a Dofile, except that the user doesn't really have the option of running it. It's more just like a report. The word capture means that Stata should not complain if there is no open log to close. Copied and pasted this from somewhere many moons ago when I was teaching myself what all this meant. This is not a super important command. We're not going to come back to these very often, but it is a bit of routine that you should get used to. So we'll run this. Now we're going to clear all. And this is kind of an important command. So basically what this does is remove all the data in the data set. Importantly, this doesn't stop to ask you whether you want to save your data. So be careful, right? It's going to clear everything that's in the memory. For instance, let's just use that auto data set that we had before. So this command here, sysuse, means pull up some data that came with Stata. So there's a number of data sets that go with Stata, and you'll see in the reading that there's some discussion of that. And then if I run this clear all here, so first of all, I wanted to show you this. This is an example of what happens when you only highlight one line. It didn't actually clear it. So that's a reason to be a little bit careful when you're trying to run commands just line by line. And this also leads me to the general rule for what to do. Generally, if you're running Dofiles in chunks, what you want to do is highlight a command, everything else on that line that's a comment, and then all the way up to the next comment. And we'll see that this actually clears everything if we go back here. That's just kind of a Stata quirk. So clear all does exactly that. Notice that it just vamoosed my data and it's all gone. So you want to be really careful when you're doing that. But that leads me to an important point, which is that you generally actually shouldn't save your data when you're working in Stata, at least not under the old name, because that saves over your old data. Why would you not want to do that? Well, if you transform your data in some way and you forget how you did it, which is extremely likely unless you have an eidetic memory, and or what you did is just super simple, neither of which is very probable. Probably most of us have some memory failings. I also don't think eidetic memories work like that anyways. And probably a lot of times you're going to want to change your data in a way that's more substantial than just a couple of things. So if you change your data in some way that you don't write down, and then you get results that depend on those data, unfortunately, you are in some hot water then, because your results are not replicable. So it's really important to keep a log, basically, of how you transform your data. You have two options, really. One, you can just save a new data set. We'll talk about that more later on, but I think a more rigorous and better option in the time being is to, in fact, just put all the changes that you want to make to the data into the Dofile. And then what happens is that every time you rerun the Dofile, you'll perform the same change to the data set, but now you have a record of what you're doing. And anyone else who gets your Dofile can see what you've done to obtain the changed data set. This is especially important if you're doing anything where you, for instance, drop some observations, or you otherwise basically change the underlying data set. And I didn't really talk about that too much in class, so let me just briefly show what that looks like. So remember in class, I'm going to again call the auto data set. Remember in class that we were mostly doing statistical operations, things that don't actually change the data themselves. So we did things like, for instance, we might have tabulated the make. We did that one. We took a summary of price and we wrote sum price D for detail. And you can do all sorts of other things too. For instance, you can put together a histogram of the data. By the way, if you don't remember what a histogram is, you can see some of my early slides from SOS 360 and all of this sort of thing. These are all basically statistical operations, numerical or graphical, and they're not actually changing the data set in any way. But I could do something like, for instance, maybe drop an outlier. So let's look at some outliers. You might recall that a box plot is a good way to identify outliers. So we can write graph box. Let's say we want to identify outliers by price. And we'll see here that it appears that observations, let's just make it simple, above $10,000 are outliers. So let me show you what happens. Let's do it like this. So first I'll show you where the data live in Stata. So we'll go to data, go to the data editor, and we can either set it up in edit mode, usually not recommended because you don't want to directly make changes to it, or browse. And we'll see that this looks a lot like an Excel data sheet here. So there's just this matrix of data, and we can scroll this bar on the bottom. Again, some of this stuff is going to change, like the exact location of these things will change depending on your exact version of Stata or your operating system. I'm actually running a couple of different versions of Stata on a couple of different machines. That stuff really, again, it's not super important. It's easy to look up, but it's something that I don't need to be alarmed by. Okay, so we can see here we have 74 observations. Let's just try rerunning one of these commands here. And again, here's a reminder of how you can use the history window to your advantage. Just double click. And we just reran the tab make command. You can see it appears again. Notice that there is nothing that happened to the data. So that was basically, we weren't in some way modifying the underlying data set. Okay, now let's use the drop command to drop those data. So drop if price exceeds $10,000. I'll explain the logic of these conditional commands later on. Now notice we deleted 10 observations. And if we come back here, we can see we now only have 64 observations. So we have in fact changed the data in this case. And basically that's important because now we don't have the same data set that we started with. And so if I were to now basically, let's do this. Let's take the sum of the price again. So here the mean is $5,159 if we round. And if we go back and compare the results from before, notice that we've actually dropped the price significantly, which makes sense because we dropped high price observations. So of course the mean had to go down. But for instance, if I were working on this data set and I forgot that I were working with this data set, and then I sent it to someone and said, hey, here are my results, or I didn't send a Dofile, but I said, here's what I got, the other person would fail to replicate what I got because they would get this without the drop data. So it's really important to keep track of that stuff. Yeah, So that's the spiel on saving things. So for the time being, generally, you don't need to save your data. Just make sure you save a copy of what you did using the do file. And again, I would recommend at least occasionally backing up your do files either by emailing them to yourself periodically, or getting an external hard drive, or putting it on Google Drive. That's an advantage of WinStat, is that that stuff is kind of done automatically for you. At the same time, it's a good skill to just generally back your stuff up. So if this induces you to just start backing things up more generally, so much better. That's a good like computer life skill that I think you would walk away from the course with. Okay, back to the main theme. So now we're going to do set more off. This is an historical thing, more or less. Stata used to, Stata's been around since computer memory was vastly more expensive, and you had to be much more careful in allocating it. The book will say a little bit about that as well, that I'm not going to get into here. But a related consequence, not directly related, is that we used to, basically, Stata commands wouldn't show the entirety of the output. So here we're forcing Stata to do that, basically. Again, this is not going to be a common command. And now, at this point, as I mentioned, we need to talk about how to set up a working directory, which is basically a place where Stata knows to go grab data from and to save output to. And for that, we need to go back to the slides, because I think this is a little bit easier to show there. And we're going to make a folder. Directory, by the way, is just a folder, and vice versa, more or less the same thing. So let's come back up here. By the way, this is just a summary of kind of what's going on in the do file, since there's a lot. So I want to talk a little bit about file structure. So first of all, you need to know what a folder is, which some students may not have had to learn before. In general, don't be afraid to ask me if you don't follow something because you have a general computer question. Okay, so a folder is basically on a computer analogous to what a folder is in real life. It's a place to store documents. We call those documents files on a computer. They can include things like Word documents. Document is in the name, but everything that you basically would want to open and use on a computer is a file, whether it's a PDF, a data set, FLAC, or MP3. FLAC is just a kind of audio file. MP4 files, so like video, WAV, for instance, all that stuff. All those are files. So files live in folders. Even if you don't necessarily organize them into folders explicitly, it's contained in some folder on your computer. But it's a good idea to explicitly put stuff into folders based on some kind of conceptual relationship between the files. So it's a good thing to do generally, but for Stata purposes, especially at a high level anyways, it's almost essential. So we're going to go ahead and make on our computers a sort of set of nested folders to use for this course. So I will do that here. I would recommend doing it probably on the desktop. You can also do it in your downloads or your documents, but let's do it on the desktop. If you use a Mac and you take a lot of screenshots, you may have this area filled with screenshots. I would recommend creating a folder and placing the screenshots into that folder, and possibly changing the place that screenshots save, which is a total side alley, so I won't get into that, but it's pretty easy to Google. And that'll help keep things kind of clean. So this is a little bit Mac specific, but again, some of this stuff is fairly easy to look up, and it'll also look pretty similar. So I'll just go over the general outlines, try to avoid being too Mac specific. So let's click on new folder. And we're going to title this, well, we can title it really anything that we want, but you'll see here that when I wrote this actually on a different computer, I'm using a backup computer I have because it's got less stuff on it, so it's a little easier for me to show how to do stuff from scratch. You'll see here that I actually called this folder this. So why don't we use this? By the way, you don't have to. You could call the folder whatever you want, and I'll show you how to swap out the name. So let's call the folder that, just for simplicity. And then we're going to come back here, and I mentioned that you should make 4 folders within it. So we'll call those do original underscore data, modified underscore data, and figures. So we'll come back here and do that. So let's do original data. modified data, and figures. Okay, cool. Let's go back to slides. By the way I'm tabbing between programs quickly is Command Tab on a Mac, another useful shortcut. So those are the 4 folders we wanted to make. And basically, yeah, you can see the product here, although I just showed it to you. If you want to pin this to your favorites for easy access, that's not a bad idea. So why don't we do that? You can just drag and drop. We need to back up here and do that. So we'll come here. There's probably a comparable sort of setting on Windows as well. Again, definitely not strictly necessary, but it makes it easy because now this will open with every Finder window, as you'll see here. And now we want to go ahead and put our data set for this course into that original data folder. Canvas was having some trouble with the large size of this folder, so I'm going to go, oh shoot, this is actually, sorry, that link is no good. Let me go get the correct link and place that in there. Sorry about that, folks. Yeah, so this is the one that we actually want. I'll replace that in the slides. So we'll download this. This is fairly large. It's going to be near a gigabyte. The other reason I'm using this backup computer, as I mentioned, I have a pretty meticulous approach to collecting and listening to music, so I barely have a gigabyte left on my personal computer as well. So this will take a while. Okay, and so this is finally zipped and downloading. Yeah, still gotta wait a little bit. Okay, so we can see that the data have finally downloaded. So let's move this file basically over to where we can just use the favorites option here. We're going to move this into our original data folder. And we can do this in a couple of different ways. Probably the simplest way is to actually just go in and copy the stuff out of that folder I called course data. And we can just, probably the easiest way is to use this view, highlight everything, open this, and voila. And this will probably take a little bit. Okay, not bad. So basically, this has a bunch of data sets that we'll use throughout the course. You can see there's a whole range of stuff here. So now we have some of the data that we'll use in the course. There's some other data that you want to download from Stata's website that is part of the reading, and it's data that correspond specifically to the book. But yeah, that's what we use for our course. So let's close these things out. We want to go ahead and put those in our folder as we did. And so now we can go back to Stata and set our working directory. As I mentioned before, it basically tells Stata what region of the computer to look for data in and where it should store results. It's an important part of the process of constructing a good Dofile. Okay, so we need to set our working directory. And if you've called the folder something different, and actually even if you haven't, because notice that this file path includes a reference to my computer, and actually not even this computer that I'm on, so I'm going to do the same thing you'll do. We need to change the file path to a folder that is actually on your computer. So the way to do that, again, this will vary slightly with Macs and Windows. In this case, this is so important that I looked it up for Windows. So for Mac, what we're going to do, right-click the folder, hold down the Option key, and select Copy Folder Name as path name. So we'll come here to Do, we'll right-click, we'll hold down the Option key. You can't see me do that, but just trust that I'm doing it. We'll copy this as a path name. We'll come back here, and we're going to paste it inside of these quotation marks. Putting stuff in quotation marks in Stata tells it that it is basically a string, or that's one function of putting stuff in quotation marks, and a string is just a set of non-numeric input, basically. So you should do the same thing. If you have Windows, you want to hold down the Shift key, right-click the folder, and select Copy as path. Okay, sorry, folks, had a bit of a computer glitch there. So now we want to go ahead and actually run this command to change our working directory. So we'll go ahead and do that now. And now we're going to use a command that we won't often use. We're just going to go ahead and check that we've actually set the working directory correctly. So we'll write pwd, we'll run that, and we can come here and see we have correctly set the working directory to the subfolder within Social365 SP22. Again, you don't have to use this exact naming convention as long as you get the name for the folder in the way that I've done. You'll always need to change it out because this will always go to somewhere on my computer. So if you're changing it anyways, it's fine to use a slightly different name. But we've set the working directory correctly to that do folder within this folder. So let's go ahead and use the GSS data that we'll be working with at times. Many of you have probably seen these data before. If you have a working directory where you mix do files and data, which some people do, then you could simply use the use command. So you could just write use space GSS 2018, and that's super convenient. But there's something to be said for a more architectonic organization. So now what we need to do is go ahead and get the file path for the data in order to use them. But we can also just see, so we could go grab it from here, but we could also remember, and this is one benefit of setting a working directory clearly, that we could just go use this prefix here because we know that we want to pull this from a subfolder, the folder we've been using. So we can come here, just paste this in here. And we can just remember or double check what we called that folder. We called it original data. So we can come back here and write down original underscore data. And you can see that pops up here, GSS 2018. And that was, convenient or more convenient in a certain sense than having to spell out exactly where these data are located on our computer. If you set a working directory, well, so Stata always sets a working directory or has one in mind, whether you consciously set it or not. And then it can be kind of a pain if you store the data somewhere different than where Stata thinks your working directory is. So even though this might have seemed a little bit clunky, we at least know how to quickly tell Stata where to grab the data from. If you're just saving stuff in whatever place, some things in downloads, others in documents, maybe some downloads in a folder, others not, this is all going to be even more complex. So this might seem like it's taking a little bit long, but what we're doing is making sure we can do things systematically. So let's run this command. And we can see that we've done it correctly because our variables window is populated with a bunch of variables. And now I can show something in class that I alluded to a few times, which is that we have so many variables here. We might want to pick through those variables. So we can use this magnifying glass, the search bar, to look for, let's say, income. You can see there's a lot of different variables that have to do with income. So much bigger data set. We're not actually going to do a whole ton with this today, but just for the sake of showing how to load data. And yeah, important point here, it's generally difficult to tell Stata where to save a do file from within a do file itself. So even though I'm going to show you how to do a lot of stuff from within do files that people otherwise do inefficiently through the interactive features of Stata, the saving process is something we generally need to do outside of the do file. So let's go ahead and save our do file now. And we can click Save As, and we're going to make sure to put it in the do file folder. So we'll come here, we'll save it. And incidentally, you may want to change these things on your computer and then go ahead and save it. So you're welcome to save for my lecture. If you ever do something that changes it in some way and you are wondering, like, how can I get the original copy? You can just go to the course website. So there's no problem in saving your own version of the do file. Now we want to go ahead and create a log of our data. We're almost done with the canonical header. As you can see right here, in the future, this is what you'll have as your header, up from capture log close to log using, and then you can just use the data that you want to use. So a log file basically is something a little bit like a text file of results that'll live in our directory. So we want to go ahead and go here, log using lecture 1. And we'll see in a moment that we'll need to do some more coding first, but basically we'll see what a log file looks like soon enough. And this replace option here, by the way, these commas and then additional commands are what are called options. So they basically modulate in some way how a Stata command works, tells it to save over any past copies. If you don't do this, Stata will get grouchy at you every time you try to run a program, because you'll be trying to create duplicate log files. So basically what this does is ensure that like whatever was previously called lecture 1 on your computer is now replaced by this log file. Yeah, another note here, a good reason to put all this stuff at the top of your do file, by the way, and not have all of this stuff here is that, for instance, log files will only log what comes after them. So you don't want to put a whole bunch of stuff before them. Yeah, another incidental comment. Some people disagree about the best name for log files. Some people say you need to have log files be identical to the do files. I don't think that's necessary, but it should be clear. So they should be, something that is obvious and somehow relates to the do file itself. If you're, looking for a simple rule, just use the exact same name. There's nothing wrong with that. Okay, so as I mentioned here before, this lecture isn't focused really on a whole lot of actual commands in Stata, but if you want to remind yourself of what Stata can do or help motivate some of what you're doing, like I said, you could see that data analysis project in the drive that I linked. But just as an example of some quicker, simpler things, I'm going to use an example that some of you are probably sick of hearing about because I use it in a lot of classes. It's a pretty common sociological research question. Let's look at the relationship between education and spouses' education. So here's some stuff we can do in Stata, and I'll just show you one benefit of using a do file, which is that you can run a lot of code really quickly. So let's just run, a few things here. I don't want to run all of this. So you can see Stata is going to run several different things in the background. One slight downside of do files is that Stata won't open multiple graphs at the same time. So you'll see here that there's only these 3 windows, the results window, the graph that we have open in front of us, and then this right here, which is the first thing I pointed to is the do file, but you get the point. So we have these 3 things here. So Stata has automatically closed the graph that is implied here by hist educ %discrete. And it's only showing us the histogram of the respondent's spouse's education. But we'll talk about saving graphs later on, so you don't have to worry about that. So you can see I ran a few different commands here. I can check out the results of the numerical analysis, which don't disappear up here. And then I can look, for instance, at the graphical output here. I won't spend a lot of time commenting on what these things are, but hopefully this feels somewhat familiar to folks. So let's look at some of the other stuff we can do. For instance, we could pull up a box plot of a person's education and their spouse's education. And we can see here, these generally seem to be pretty similar. So we might want to do some kind of an analysis that investigates the extent to which these 2 things are positively related. So we could run a regression model, for instance. And we can see here, there's a pretty strong coefficient, obviously statistically significant, and does a pretty good job of explaining variation in the outcome, even though it's mere bivariate analysis. So We can do some post-regression diagnostics. For instance, we can see, we'll see in a moment, what the residuals look like. So basically whether or not there appears to be any omitted variables, but let's just show a canonical scatter plot with the regression line first. We can see this looks like it fits pretty well. So evidence that this is a good model. Briefly show the regression diagnostics. Again, if some of this feels a little bit unfamiliar, that's totally fine. This is just testing to see whether or not there's evidence of an omitted variable or some lack of evenness in the error term. There seem to be some clear outliers at the bottom end of things, but otherwise looks pretty good here. Okay, so that's just a quick example to show you some of the stuff that Stata can do. If you haven't seen Stata before, hopefully that seemed kind of cool that I can pull up all that information relatively quickly. That was an example I wrote up in all of 2 or 3 minutes. So once you get proficient with Stata, these things are easy to do and fun. Okay, I don't have a whole lot more to add because you'll see a lot of this document just shows you how reading notes work, and I won't walk through that too extensively. But I want to briefly talk to you about how comments work in Stata. These are discussed in Mitchell's appendix, but there's a bit too much advanced material interspersed that I don't actually need you to learn yet. So I just want to make a brief comment on that. First of all, we've been using this manner of doing comments, what I would call effectively the parenthesis method. So we basically start and end a comment here like this. So / asterisk, and then close it with asterisk / There's actually 3 types of comments. The one that I learned first, and that you may have learned at some point if you took a course with someone else, is this to / method. But one problem is that it runs out after each line, so we have to retype the double / to keep it going, which is slightly annoying. Let me show you an example. So this actually not a good example. I should have shown you what it looks like when it doesn't work. So let's do this. So we'll say, here is an example of what goes wrong. Okay, see, this is a problem now because if I run this, Stata is going to get grouchy because it's interpreting goes as command. Conversely, if I do this, I use the parenthesis method here, bracket method. Those are both slightly confusing because they aren't literally parentheses or bracket. This method is nice because you can write multi-line comments. So go ahead and delete that because we don't need it. But you could use this double / method if you have a comment that's really short and can just stay on the same line. So for instance, if I'm writing something like this, reg PyDuke, this shows a regression of mom's ed on dad's ed. Then this is appropriate because I don't really need to go to the effort of opening and closing this comment because it's very short. We also have this asterisk option here. This is the rarest, but I do want to show it to you. You may see it sometimes. This works a lot like the 2 /. There's really only one advantage, which is that it can be used in the command window. It's not really clear why you would ever want to do that, to be honest, but it's sort of interesting to note. So let's show how that looks in the command window. So we can come here, and this is an interactive comment. Interactive in the sense that I immediately am returned a result from the code. The Dofile is not interactive in the same sense. But notice that this doesn't work for other things. So we can try like this, testing, and we get this error term, or testing, and we get this error term. So this is the only way. But again, it's not really that practical. Okay, so we'll mostly use this style here, which is less typing intensive. Just remember to close the comment by writing another asterisk and /, but in the reverse order. A couple of last comments here. So you might notice that here I've been avoiding going too far beyond this line. I called it white because I was using the night mode version when I wrote these notes originally, and now it's kind of grayish. But what it does is prevent your log files from spilling over too much. And that's incidentally, basically the last thing we'll do is finish up with log files. So let's go ahead and end this here. These are just example reading notes from now. So let's go ahead and close this and examine our log file. So we can close this. We've changed the do file somewhat since I was adding and then deleting things. I'll just save it here. We've already chosen the location. Now we're going to go ahead and close Stata, and we'll be asked whether or not we want to save the data in the memory. We're not going to save because, again, any of the changes that we are going to make, for instance, if I really did want to drop certain observations, I would just put that information into the do file. So we'll talk more about that later. You don't have to know exactly what that looks like now, but just letting you know why you don't want to save the data. And let's look at the results of what we did. So we can come here and we can see now that we have this SMCL file, which is a log file, and we can open this. This is going to open Stata again. This is a lot like a do file, as I mentioned before, but it's nice in that it also shows the results from the command window, basically. So it's kind of like a way of saving our entire session, so to speak. And we can see here basically everything that we got. The one thing that's a downside is that we can't see the graphs, but other than that, this is pretty useful. So sometimes I'll ask you to turn in things as log files, and the log file will basically just live in the same directory as the working directory. So that's pretty much everything I have for you all. Hopefully this was informative. Please feel free to reach out to me if you have any questions. It was really great to meet you all today, and thanks for your patience as we work through some kind of fundamental material with a couple of tech things here and there. Basically, what you need to do for next week, read chapters 1 and 2, which are linked here and here. Show you, oh, I guess I need to make sure to enable these things so you all can see them. That's important. I'll do that in a moment. But the other thing that you need to do is submit your reading notes. And I double checked earlier that this is open. So you can just submit this as a file upload. As I mentioned before, I put an example like for chapter 1 in the first lecture do file. So just again, I just showed this, but just so that no one is confused, they're at the very bottom of this document here. I put in a lot more detail than you really need to put in part because I just like to share knowledge where possible. So I happen to know a good bit about Stata at this point, so I put in a lot of that knowledge. You don't obviously have to know the same level of stuff at this point, so your notes don't have to look that much like mine. I made the file upload here kind of flexible because we have a couple of people that might be submitting things in different ways based on their situation, but unless you've spoken with me about an alternative arrangement, please plan to submit a do file here. So that's all I have for you all. Thanks so much. I really appreciate your time, and I'm looking forward to seeing you on Monday.